Okay, welcome back. This is our last topic in Unit 1, talking about the idea of transformations of functions. And again, this topic could be used to describe how to graph functions based on transformation. That's not what we're looking at here. We are going to look at graphing functions, later on throughout the year at different points, but that's not really the goal here. The goal for this is just to describe what are the types of transformations are occurring. So we have three main types, the first one of which is the idea of translations. This is shifting things up and down when we translate vertically, or left and right if we're going horizontally. The direction, how we go, how much we go will depend on the number and the sign. So if our basic parent function is the absolute value of x, then we're doing x plus 3, that's shifting left, x minus 4, we're shifting right, plus 2 outside is shifting up, minus 5 outside shifting down. And this applies no matter what the function is. So it doesn't have to be an absolute value for this to work. Any function that has the inside the function itself, adding directly with x or subtracting directly with x is a horizontal shift left or right. Adding or subtracting outside of the function is a shifting up and down based on those signs and that number. Your reflections is where you're going to be flipping the function over either the x or the y-axis. The location of the negative sign will determine what type of reflection you're dealing with, whether it's over x or over the y-axis. So if the negative is multiplying with the function outside, then it's reflecting over the x-axis. Where if it's multiplying inside the function directly with x, it's reflecting over the y-axis. And here we're using the square root of x as our basic parent function to demonstrate where the x would go. So this could easily apply to the absolute value from before, any other future problems we're going to deal with for these types of problems. Our final type of transformation is the idea of dilations. This is how much we are stretching or shrinking these functions, either vertical or horizontal direction. The more technical terms being compressing or expanding. The value of the number that's multiplying with the function and its location will determine the type of dilation. Please note though, if it's a negative number multiplying, the negative is talking about a reflection, and then the number itself is talking about the dilation. So they'd be two separate transformations. All right, continuing with the theme, if we are inside, we're talking about a horizontal type of transformation, so 2 times x inside of being squared. If it's an integer, we're compressing it horizontally by that number, so by 2. Whereas if it's a fraction inside, then we're expanding it horizontally by the reciprocal, so by 5 is what we would say. If it's multiplying outside of the thing, so the 4 is not being squared, the 1/3 is not being squared, whereas the 2 and the 1/5 were in the previous problem, we are expanding vertically when it's an integer and compressing vertically when it's a fraction. And yes, certain things, so in terms of like practicality, in terms of like making a graph, 2x squared, the expression is the same thing as 4x squared. So graphically, compressing horizontally by 2 in this case is the same as expanding vertically by 4. That's not what we're trying to debate here for anything like that. So just simply go based on where the original location is. Don't try and foil things out or square things out or move things. Just go with the original location for these types of transformations. All right, so we're going to do a couple of each type just to get an idea of what's happening. So here our basic function is f of x equals 5 to the x power. That's our parent function. And in the transformations, all the things are different about that. So first thing I'm noticing for g of x, I got a negative and I got a 3. Those are two separate transformations. Then I have a 2 multiplying with x and then a 6 subtracting with x. And then we have a plus 9 at the end. Now, to go through these transformations, transformation 1, 2, 3, and 5 are relatively straightforward. 1, because it's a negative multiplying outside the function, not directly with x, is a reflecting over the x-axis. An integer multiplying outside, not directly with x, would be vertically expanding by 3. The 5 is not a transformation because it's part of the original parent function, so it's the base. The 2 that's multiplying directly with x, that's now horizontal, and because it's integer, that's compressing. So we have a horizontal compress by the 2. I'm going to come back to that 6, and the plus 9 at the end of the whole thing means we are shifting up 9. Now, all of that can be easily done based on what it's originally looking like. For the horizontal shifting left or right, to properly describe the left or right shift, this expression right here, the 2x minus 6, we have to factor whatever's in front of x away. So instead of being 2x minus 6, it's 2 times x minus 3. So the minus 3 is really the proper shift, so it's really not shifting to the right 6. It's x minus 3, so we're going to shift to the right 3. All right, so even if it's just simply a negative sign, anything that's multiplying directly with x must be factored away from the entire x expression there to properly identify the horizontal shift left versus right. Luckily, this is the only one that this applies to, so you can do all the other types of transformations without any other difficulty. Any of the reflections can be identified just by recognizing the negative, compressing or expanding vertically or horizontally by the type of number and its location, and then shifting up or down the outside number adding and subtracting. Just the shifting left and right you have to be careful with that transformation. Okay. We'll take a look at this one right here. So we're recognizing, again, we're going from square root of x to something else. So that 3 is different, the -1 is different, the 1/2 is different, the 6 is different, and the -1 is different. And again, to properly identify the horizontal shift, I have to factor the -1/2 away from x and -6. Now this becomes an x plus 12. And if you're wondering, well, wait, why is that not a 3? What happened? Why did it become a 12? You have to remember factoring means dividing. If I go back to that previous example, how did I get a -3 there? I did 6 divided by 2. That's how I got -3. Same thing for this. If I want to figure out what's going to go inside there when I factor the -1/2 away from x and -6, I have to do -6 divided by -1/2. And if I'm dividing a fraction, I'm multiplying by the reciprocal, and that's how I got the plus 12. So the plus 12 is really transformation number 4. Now, I'm listing this in order from like left to right. You are not required to list them in the same way I'm doing right now. You can do it whatever order you want. The key really is, what are the 5 transformations? That's what you want to look for. So transformation number 1, it's an integer on the outside, so we are vertically expanding by 3. Transformation number 2 is a negative multiplying directly with x. That's now reflecting with the y-axis. Transformation number 3, it's a fraction multiplying directly with x. So it's a multiplying directly with x, so it's horizontal, and it's a fraction, so it's also expanding. We don't say by 1/2, though, we say by 2, the reciprocal. We recognize that horizontal expansion means a fraction, so we know that really is a 1/2 there, but we say it's expanding by 2. Transformation number 4, now we've done our proper factoring out the -1/2. We know it's really going to be shifting 12 to the left because of the plus sign. And then our -1 at the end means we're going to go 1 down. All right, so again, if you want to write out the vertical and horizontal with its full words rather than just doing V or H, that's perfectly fine. You do need to make sure you specify whether it's vertical or horizontal, because they're both expanding or compressing. You need to know which one is which. Like, you're not going to make the mistake for shifting up or down, left or right, because those are different words. But expanding and compressing could apply to both vertical and horizontal, so we need to know which one it is. So you do have to specify the type, vertical versus horizontal. Now that's where I give you the transformation function. You figure out what happened. Here, I'm now giving you what's happening. You need to write to the transformation function. So when doing this, I tend to give myself plenty of space initially so that I can have room to kind of like write numbers factored in or multiplying with in front or anything like that. And I just kind of go in order of what it is and just kind of see what's happening. So shifting left 3 means I'm adding 3 with the x. Shifting up 2 means I'm adding 2 at the end of the function. Reflecting over the x-axis means a negative multiplying outside. Expanding vertically means an integer multiplying outside, and it would be a 6. So it's a -6 times that 7. And expanding horizontally by 2 means I need to have a fraction, a 1/2, but it has to be factored away to properly show the horizontal shift there. So that's why g of x is -6 times 7 to the 1/2, factored away from x plus 3 plus 2. There we go. We got all 5 done. So if you leave yourself enough space, so that's really, you want to make sure there's a space where you could put the negative and the number multiplying with the function in front. You need to leave space so you can have something factored away from the x expression in the exponent or inside or wherever it's supposed to be. And obviously you have your space at the end to do your whole plus or minus something at the end. All right, so here, so we want to find our g of x, which is based on the square root of x. So again, we have our square root symbol. Give myself enough room inside there and an x right there. Compressing horizontally means it's an integer inside, so I'll be a 2. Probably be factored away though, so I'm going to put my parentheses in right now. And good, because I'm going to shift right a number down. So let's say we're going to shift right by 7. So that's x minus 7. We are shifting down 3, so that's minus 3 at the end of all that. Reflecting over the y-axis, so it's really a negative 2 then, because remember there's separate transformations. And then compressing vertically means it's a fraction on the outside, so it's 1/5 on the outside, compressing vertically by 5. And there we go. Biggest thing you need to be careful with is the idea of factoring away the horizontal or the horizontal expansion or compression from the horizontal left to right shift. And then obviously the reflection with the y-axis. That needs to be taken care of. That way you're properly writing out the expression. Without it, like, you're welcome to then go further and say, okay, g of x then is really 1/5 square root of negative 2x plus 14 minus 3. Like, that's perfectly fine. Like, that's how you've been given to start off with to identify the transformation, so it's fine if you distribute that. I have no issue with that. So it's just kind of up to you right there. All right, so that's it for Unit 1. So that's your basic function notation there, function types of problems. Unit 2 is going to be all about polynomial functions, so we're going to get into the idea of reviewing basic quadratic factoring, other types of quadratic rules, completing the square, getting into division methods, solving, writing, stuff like that. So I'll see you next time for that series of videos.